Wij gaan back to the future.
Jan en ik gaan op 17 april naar de Microsoft Technologies en .NET conferentie van Nederland. FutureTech 2024 in de Jaarbeurs Utrecht.
Hey, weet je wat echt super tof is?
Nou, vertel.
Wij mogen gratis kaartjes weggeven. Wat moet je ervoor doen, Ronald?
Nou, dat is heel simpel. Volg ons op TikTok. Daar zijn wij tegenwoordig ook te vinden.
Vet, hoor.
Ja. En op YouTube en maak kans op 2 van deze tickets.
Ja, vet. Hey, mis je kans niet en dan zien we jullie daar.
Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes Podcast. De podcast over Kubernetes voor iedereen. Ik ben uw gast Ronald Kers en ik zit zoals altijd met de enige, echte...
Hallo Ronald.
Jan Stomphorst. Welkom Jan.
Ronald, we zitten hier via Zoom, maar wel met mijn grote voorbeeld.
Jouw grote voorbeeld. Ja, daar heb ik je heel vaak over gehoord inderdaad. Ja? Dat je een grote fanboy bent, hè?
Ja, ik ben een groot fanboy van Crackbox. Zo.
That he understands. That he understands. Well, just to make the switch to English then, welcome Greg Box.
Hello, thank you very much for having me.
Yeah, great to have you. This is a podcast long in the making, and we all the way from New Zealand, and one of the founders of the original Google Kubernetes podcast, if I'm not mistaken. That's what Jan is the big fan of. So for the people who don't know you yet, I cannot imagine it, but still there will be a few. Can you please introduce yourself?
Hi, I'm Craig. I used to do a podcast for Kubernetes at Google, and now I don't. There's a little bit more to it.
There's a little bit more to that, yeah?
I'm glad that you guys are carrying the torch forward. Someone needed to come forward with a good Kubernetes podcast in my absence, so thank you very much.
Yeah, we're welcome to fill the void, you know, that you left. So how did you get started in the IT and in that way also with Kubernetes?
Yeah, so there's probably 30 years between those two different things. I'd say started in IT was a career choice from birth, if you will. My father works for the National Telecom Company of New Zealand. He's worked there for over 50 years now in its various public and private incarnations. And he was the kind of guy who was playing around with tech and computers in the 80s. And he brought home a VIC-20, and that became a Commodore 64, and that became the only thing I really cared about for quite a few years, and moved on through PCs and so on, but then also moved on through parties and socializing and throwing events and all sorts of things. So when it came to studying technology, it wasn't something that I wanted to do as a programming based career. I didn't want to see myself locked away in a basement. I knew I could go out and talk to people and have fun. And I really wanted to take advantage of the fact that I could talk to anybody. So I did a bit of contract IT work and consulting based here in New Zealand. There's not a lot of exciting stuff to do. We were definitely no Silicon Valley back then. But then went overseas, worked in Canada for a couple of years at a consulting company over there, building document management software, and then moved to the UK and worked for the Symbian Foundation, if you remember Nokia mobile phones.
Yeah,
really
fondly.
Experiments with open source.
Yeah.
And that got me into working with cloud. So that was my first experience working with cloud, was migrating their infrastructure to cloud and working with two sets of technologies, with the cloud technologies that I was interested in from having a sysadmin background, but then also with the Google Workspace technologies, Google Apps and so on, Google Search Appliance. And that led to a consultancy working with Google, and that led to working at Google itself.
And how did the podcast came to be?
The podcast was something, I guess, that, again, as a communicator that I was interested in doing. I had a little bit of a background in radio, very small background. When I was at high school, we had a little toy radio station. And my colleague Adam he'd done radio a lot more seriously when he was at university. And we both kind of in that sort of figuring it out at the same time, we both knew we wanted to do this. There wasn't really anyone covering the space. There was sort of only one podcast that Red Hat was doing, talking about Kubernetes. He was in marketing, I was in developer relations. So it was really an idea of like bringing the things we wanted to achieve for our
Yeah, sounds familiar.
So, yeah.
He's the tech guy, I was the marketing guy, you know?
The glasses and the hair. It's you and Adam dead ringers for each other. But it was to have that, build that community. It wasn't like, even though it was, for better or for worse, branded the Kubernetes podcast from Google, it wasn't of Google. It was in the same way that Kubernetes wasn't. It was founded there, but it was really about a community and about people speaking with one another and sharing that. And we did, I think it was 190 episodes by the time I left, and Adam left a couple of years before I did. So he, unfortunately, upon his leaving, had other things to do, and so
life happens
with some guest hosts and so on. And then upon my leaving with Google, as much as I would have loved it to continue to be a community thing, it was decided that they wanted to keep that inside. So I haven't really paid much time to it since.
I was wondering, how was Google open for your request or open for your
starting a podcast?
Yes, starting a podcast.
Yeah, so it was the second podcast out of the cloud division. There were possibly more at Google at the time. Podcasting wasn't something that I'd say was necessarily in Google's DNA. They're very big on video, and they're very big on things that you can measure. And a podcast is like, well, I've recorded this thing in my room and put it out there, and I can say this many people downloaded it, but I can't say whether or not they listened all the way through or clicked on any of the ads or anything like that. So it just comes down to the fact that the developer relations team at Google have a very long rope and can do anything that they think helps meet their goals. So there was a Google Cloud podcast, which had been around for a couple of years. And we spoke to the team who put that together and sort of figured out how they got started and some of their infrastructure choices. And we replicated some of them, which in retrospect, they were all like, let's build this custom thing on App Engine because we want to show we're doing Google Cloud stuff. I'm like, well, by the time we got there were third-party services, and perhaps we should have just used one of those. But we built everything out, launched it, I want to say 2017, 2018. I lose track, but
2018, April.
April, yes. So it was at or around the KubeCon.
You see, he's a fanboy.
KubeCon. I like it. Someone, you're going to tell me, like, oh, remember on this episode, like this, the Simpsons fans. It'll be great. But yeah, we were able to launch. I actually was doing a sponsored keynote at that KubeCon. So two things that Google announced that day. One of them was the gvisor, hypervisor for securing binaries, and the other one was the Google Kubernetes Podcast.
Cool. So when we talked to you in preparation to this podcast a few months ago now, you also told us about a project Borg, if I'm not mistaken. Do you recall?
I'm not sure we're allowed to talk about that. That's still secret, isn't it?
Oh.
Borg was the code name for the system that ran containers within Google, that ran the ecosystem. If you squint at it, it looks very much like Kubernetes. And the history of this and the secrecy around it, like there are a couple of different sort of memes about why it was such a big secret. The first one was that they didn't want the Star Trek lawyers to come down.
Well, that's a hard thing to do when you name it like that. Being a collective and all with containers, there is a kind of a thin line to walk on. Yeah,
it does come in. There is a direct line that we will draw to Kubernetes in more ways than one momentarily. But basically, the system that was required to operate all of the things at Google at this kind of scale was somewhat secret in the sense that the example I used to give is that Gmail launched in. You're going to tell me that it was definitely in April. It was April 1st sometime, but 2000 and something. And it was everything at the time was giving away 40 megabytes of email, and Google could give away a gigabyte. Everyone was just astounded. Like, how can you possibly? Your margins must be so thin. You've got one tiny ad against things. How can you afford to do this? And the answer to the question of how Google could afford to do anything was that they were doing more with less. They had a system that allowed them to take machines, which normally you just throw one piece of software on a machine and it might peak at 20 or 30% utilization. What they did is they said, right, let's take these and use the computer science knapsack algorithm or the bin packing and say, right, well, we've got 4 things that use 20% of a CPU each. We can put 4 of them on a machine and we can still have a little bit of room to breathe. And so the system that built that was this sort of, again, collective that managed a series of drone machines as if they were one big thing. And there are books now and white papers that have been published from Google about how this all worked, but the idea of treating the data center as if it is a single computer. And that was a competitive advantage. That was a very secretive thing because Google didn't want other people to be able to offer a Gmail-like service at the same price.
Yeah.
Awesome. And
no, well, I still the Borg. Yeah. Or Kubernetes. There's a link there.
There are many links. So I wasn't the biggest Star Trek guy, and I find it interesting because all the people, like the interns who had come into Google in the last 10 years or whatever, they were 20 years old. They'd never heard of Star Trek. They had no idea of any of these references. Like, you had to have not only watched Star Trek, but you had to have watched it between 1987 and...
I said this was a very specific time window, yeah.
It was. and so, here we go. And again, this is not my story, but I will tell it. Do you remember, I think, I'm going to say it was Deep Space Nine. There was one of them. There was the human Borg character played by Jerry Ryan.
Yeah, it's Voyager.
The Voyager.
Yeah.
Yes. And her name was Seven of Nine.
Yes.
Mm-hmm.
And the character was, she was perhaps, I'll use the word prettier. She was a prettier version of Borg.
Yeah.
And so the project at Google to release a prettier version of Borg was Project 7. That was its code name.
Yeah.
And that lives on. If you see the Kubernetes logo, it's actually a ship's wheel with 7 points on it as opposed to 6, what you might normally have. So a lot of these little lineage things continue.
Yeah. It's funny. It's really tech inside joking or...
You had to be there.
Yeah, you had to be there. Yeah.
Between 1987 and 1994.
Yeah.
And what sparked then to start Kubernetes? What made Google starting Kubernetes instead of still using Borg?
Borg was a giant application written in a very monolithic way, in a very traditional programming language in C++ to solve a Google problem. Google released a few services based on those patterns, things like Google App Engine. And in the early days, they were releasing things that if you were able to write code like a Googler would, you were able to run something at that kind of scale. But you had to use these weird data stores that were only eventually consistent, and you couldn't do SQL queries on them the way that everyone was used to doing. So going into cloud versus people like Amazon who are like, here is a VM, here is a MySQL database on top of that. It was a lot easier for people to adopt those kind of things. Around that time, a couple of things were happening. So first of all, Google was trying to become a cloud provider. They were taking these internal services, releasing some of them. But like I say, you had to really write the way that Google wrote, and people wanted to have the way of interacting with services that they were aware of. And the second thing that was happening was the launch of technologies that were available inside Google and were very complicated, being made easy by people on the outside. And the canonical example of this is Docker. People at Google were some of the inventors of what we think of now as the Linux container, or the C groups technology that allows the kernel to segment applications like this. But that was complicated and hard to use when it was upstreamed, and there were some things that were trying to make it easy, like the LXC project. But Docker came along and made it trivial for developers to build and deploy software.
Yeah.
The problem of whether or not they could do that at any kind of scale, though, was something that Google's like, well, we know how to do this. We know how to solve this kind of problem. And so some desire to meet people where they were, some desire to sort of adopt the outside things and build a new system that people were going to be able to maintain that wasn't tied into needing all this weird Google stuff, and wanting to launch something to help grow the cloud business. They were the things that I think brought the founding team together.
Awesome that it's become as big as it is now. If you think back,
it's a big industry.
Yeah,
I hear it's even got its own conference.
we know.
It is interesting, obviously. I don't know if you were to ask some of the people who were around in the very early days, did they think it would become this big?
Yeah.
I don't think anyone can look at hindsight and say, well, it could have been this. Like, it would have been something. And to the secrecy around Borg, like, one of the other reasons why this was allowed to happen was, even though it was secret source within Google, there were people who were starting to build systems like this outside of Google, and they weren't doing as good a job as far as the Googlers were concerned.
The Mesos.
Yeah.
Yeah, Mesos is one. I think that the inventor of Mesos had done an internship at Google at some point. Someone who's involved, maybe not the...
got inspiration somewhere.
Yeah, but the patterns, like, people move around, people see how this works. It can't be a secret forever. Facebook was building a system like this internally, or had one by that point. And when the Mesos guys got to Twitter, they sort of said, all right, well, hey, we want to build something. We see this academic project Mesos. We know what happened from the fact we've done internships at Google and so on. Let's take this and make it work. And they built their own scheduler on top of Mesos. And so there were onesie, twosie solutions inside companies. And I think as Google were building out a cloud business, they're like, well, if we can standardize this, and especially now Docker was coming along and people were starting to build this, on top of Docker. It was getting much easier because that part was solved. Then they would say, all right, well, we want to capture as much of the market as we can as a vendor. And to do that, we need to help people on this journey of how they can get better utilization, how they can do more with less, and so on. So if we can get people running in this way, to do that, we need to be very open about it. We need to publicize it. We need to allow people to run it themselves, so it has to be open source. And we then eventually need to get other vendors to buy in and offer it as a service to their customers so it becomes a community standard. And that could not have been executed better.
Now, was that also the reason why they started a foundation to put Kubernetes in?
Absolutely. Yeah. So if you are Microsoft, then you're going to look at this thing which your competitor is offering and say, oh, no, we're not going to do that. We're going to do our own thing. We don't have control over this destiny. Google could enforce a trademark rule. They could change the system. So like any other vendor in this space. And by putting it in a neutral home, by donating the trademark to them, by making sure there was a community built around that, that gave other vendors a chance to say, right, yes, we can be involved in this. We know this is something that's going to be popular. Amazon got on board when enough of their customers started asking for it. So Amazon famously build things based on customer demand, and we managed to make enough customer demand. We said, people say we want Kubernetes, and then Amazon eventually started offering that as a service themselves. So it has got to the point where everyone has a Kubernetes service. Like, it is an expectation for a hosting provider of any scale now that it's there. And that wouldn't have happened if it hadn't been given to that neutral foundation.
Yeah, you can see it also in more and more industries becoming a proprietary piece of technology. In there we had do a podcast about the gaming industry. They also say when you do multiplayer games, you cannot do without Kubernetes anymore, and containerization of service. And that you can see that in more and more industries becoming a thing.
Yeah, and it's sort of analogous to Linux. As for a while, like Linux was how you would host things on the internet. Kubernetes is an extension to that. Kubernetes is how you host things on multiple Linux machines. And shout out to, I mentioned before, the guy who had set up the original Google Cloud podcast, Mark Mandel. He was one of the guys who really took gaming on as a challenge and built some operators on top of Kubernetes to support multiplayer game.
We had him on two episodes ago.
Yeah, that was really interesting because he did something with UDP routing and but listeners have to listen that episode to get the full insights.
Yeah, but also with a new project. Just taking a step back to our podcast, what I was really wondering about, aside from the technology, what are your fondest memories thinking back at the Google Kubernetes podcast?
We did an interview with Mark Shuttleworth. He went to space.
Oh, yeah.
It was very hard to ask him questions about Ubuntu, and he was there effectively talking about the Kubernetes service that Canonical were offering, the Metal... I can't remember the name of it. Sorry. It's. I'm sorry, Mark. I was too busy thinking about space at the time. Being able just to talk to people and reach out to someone and say, hey, we have this avenue that we talk to people and you could knock on many doors. And like one thing that where I was always a little bit jealous of people like Mark is like he had a very generic podcast. He could say, hey, Vint Cerf, I'd like to talk to you. And Vint would say, yeah, sure. And you could have a chat about anything. But we'd got our little niche and we were talking about Kubernetes. So we spoke with pretty much everyone we wanted to in the Kubernetes space. There are one or two people. I had hoped to speak to a guy named Luis Barroso, who was one of the authors of the Google book about data centers as computers. He passed away a couple of years ago, unfortunately, but he wasn't so keen. He wasn't a public speaker or anyone, but I would have liked to have spoken to that. But we recorded with everyone who was like involved in the founding of Kubernetes. We did an interview with Brendan Burns, which never aired, unfortunately, because we did that one in China. And we didn't want to walk in with all our microphones and so on and look like we were journalists turning up there, and that was to be frowned upon. So we tried to do it with Chromebooks and headsets, and the service wasn't able to get outside the Great Firewall and save its stuff. And when the laptop got back to the US, Brendan was like, no, I am not plugging it in. I've set it on fire. So, unfortunately, most of that one was lost to time.
Oh. Yeah, but
I still have the first half of it, and I've been meaning, like every now and then, I'm like, I should take what I have and see if there's anything there, and release a a bootleg episode of a podcast.
Yeah, exactly. Yeah, that would be fun. You hear when an artist has died, for example, and they found like hidden records on a shelf somewhere in the storage house, and they will edit it and just publish it just for the diehard fans.
That's so tough because I have two opinions. The first one is I love this person. I want to hear all the things they've ever done. And then the second opinion is they didn't want this published. They didn't think it was good enough. It's probably bad. Don't put it out there.
Yeah, that's one way to look at it. So you now work at solo.io. Can you tell us something about your role there? What you guys been up to?
Yeah, so in the last 2 or 3 years of me working at Google, contrary to popular opinion, the podcast was not my primary job. It was definitely a large part of the thing I enjoyed doing, but the rest of the part I enjoyed doing was running the Istio community, like doing all of the things aside from engineering. To run a project effectively, you need to think of it like it's a product. And so what I was doing from my position in developer relations was treating Istio like it was a product that needed a product manager. It needed someone to help guide direction of things and bring everyone together for all the right meetings and write the press releases and rebuild the website when it needed to be promoted and so on. So I did a lot of that kind of thing. And I left Google almost 2 years ago now. I worked for a startup for a year doing security. I had a great experience there. But then I'd always sort of loved what I'd done with Istio, and the opportunity to join Solo came up. And at that point, it was like, I'm effectively doing what I was doing at Google with the same people, just being paid by someone different or something.
Yeah.
Like that's one of the great things about cloud native is that so many people can move around, and many of the people that I work with, people from places like IBM and Google, are now at Solo. Many of the people still at Google are people I still used to work with. But it's very easy to fit back in and do a lot of that. And my role is largely it has an involvement with Solo's products, commercial products that are built on top of open source products like Istio. But a large part of it is building out the things in the community. We have a big new launch of the ambient mesh that we're working on at the moment, and getting people to know about that and want to use that will drive people to want to eventually get a vendor to help support them. And so that's where I am.
Yeah, but what was your draw to Istio? What was the thing that's the company I want to do the community work for?
I've wondered about this recently. Like my background, I mentioned up front, like I didn't want to be a programmer. I was really sort of a systems administration. I would use the skill I had in programming to do things like write little PHP scripts to automate. I don't know why it was in PHP, but it was better than the M4 scripts that we used to use, the make files and so on before that. But a lot of what I did back then was networking related as well. So I've always sort of had a hand in networking. And Istio is really a project that lets you control networking with APIs in the same way that Kubernetes lets you control deployment of things with APIs. They relate to each other very well. They're very complementary to each other. Indeed, when Google was launching Istio, the question was like, should this just be built into Kubernetes? And the goal at that time was to shrink Kubernetes down and keep it to be a very tight core of things and have everything else be add-ons. So the decision was basically, right, now we will build it sitting next to the team who build Kubernetes, but we won't make it a Kubernetes thing. We'll have it be its own thing. Yeah. And there was some intention to have it support, like it supported Cloud Foundry. You can use VMs to have it be more than just Kubernetes. But obviously Kubernetes became the only thing in the room. Mm-hmm. So that's where everyone tends to use it. And it worked out really well. Like I've always been geographically distant from the teams who are building these things. And it has in some ways defined the things I can do and be good, helpful to a project. But it also meant that in terms of Google's commercial projects, it was hard for me to be influential in these things because I wasn't in the same room or in the same time zone as the people who were in the West Coast of the US. Whereas with the open source projects, like those are already happening neutrally on open mailing lists, asynchronously with people all around the world. So it's very easy for someone who is not, it's not necessarily easy, but you don't have to be sitting in the same room as people to really succeed in those things.
No.
And so I've done a lot with Kubernetes. We launched GKE, obviously. I've done a lot with internally with that, but it was those things that kind of progressed and became businesses, and we had big field teams getting involved there. And so Istio was the next thing in the space when I first got involved with that around 2017. And it was good, and I loved working with the team there, and I looked for ways to do more of that.
You said it was built for Kubernetes and intended to be in Kubernetes. If you install a cluster or use a Kubernetes cluster now, would you use always Istio in your cluster?
The question of how these things relate to each other goes back maybe to the concept of ingress and like should you be able to get traffic into your Kubernetes environment? And the answer was basically it needs to be pluggable. And so you need to be able to support the load balancer provided by your cloud or by Google, running GK especially. But then also you need to be able to plug something in. And so there needed to be an API to define how those things would be different. And you need to say, I can plug in different classes of things depending on where I am. And so that was sort of why like Istio it's good functionality, but it wasn't default really. Like it was higher level. Kubernetes
it's complex also.
A lower level. Kubernetes and Istio are both, I wouldn't say complex to a fault. Like they are designed of the fact that Google knows that people are going to have problems that you don't have today. And it's really hard, like even just looking at Kubernetes, we say, well, here's how you can deploy, like, you know how to deploy one thing. Here's how you can deploy 10,000 things. And then here are a whole bunch of knobs that you can control about how they roll out and which order they do and taints and tolerations and all these things. Like everything that was added to Kubernetes was put there for a reason. And it was largely because the people who had operated the Borg system knew that those things were going to be necessary. And it's hard for someone on day one who's learning about one of these technologies we need to hide all that from them. We need to say, you will need this later on if you're running at a certain scale. But for a lot of other people, you're never going to need to know about that. You can do very simple things. And for all the fact that Istio had a reputation for being complex, that was reasonable, but I think it was also born of the fact that the people who built this weren't just building it from the ground up. You have a lot of projects that start and say, right, I can do one thing. And then in a year's time, I can do a second thing. I can do a third thing. Not to be critical, but that was the very Amazon approach. It's like, let's put out a service that can do one thing, and then we'll iterate over time. And then 10 years later, we have an absolutely fully fledged load balancer that can do everything that can possibly be done with networking. Google Cloud, because they were opening up internal services and making it available to customers, they launched on day one with a 10-year-old product. And it had all that complexity in there. And I think the same is true of Kubernetes and Istio, is that those things are there. I saw a lovely quote recently which says, it is easier to abstract away complexity than it is to sort of make up for the fact that a feature that you want isn't available. And this is the second time I've tried to recount that quote, and I've only remembered the first half of it. So I'm really sorry for butchering it. But
that's fine.
If you have a system that can't do the things, if it's not good enough, then you can't use it. Like as easy as it is to use, if it doesn't solve your needs, then it's not there.
But they started with a 10-year-old product. That's a great start.
Everything at Google had to launch with the assumption that it would have 1 million users a second upon launch. Like there was no soft launch for things. Even when they did things like Gmail, which had invitation only, like the service, anything at Google scale had that problem. And
the Google Wave
nice problem to have.
That was also awesome. Google Wave.
I don't remember.
I remember going to an open day for Google Wave. That was the thing that you could look at and say it was before its time, maybe. But you look at things like Notion today, maybe like there is. It was one of those things that a big company with a research division would do as a tech demo, and maybe it couldn't have been a product. And anyway, whether or not Google should have launched various things and how it manages things is a topic for Kara Swisher, perhaps. But I will say to your previous question about like, should everyone run Istio? It costs a lot to run because it does it a lot. And in the way that it had to be architected, you needed to basically intercept every piece of traffic that was there. You needed to run a process alongside everything. So you effectively run your own workloads, and then you run the Istio sidecar proxy next to them.
Yeah, the envoys.
So that means the cost of running compute goes up. Like you're adding 20 to 50% on top of that to provide this. So it was a trade-off. Like if you needed those features and if you got some business value from doing that, if you could do something you could not previously do, if you were in Europe and you needed to prove to people that you were encrypting all of your traffic for various GDPR regulations or so on, then yes, you would pay that tax. You would do that. What we're doing with the Ambient Mesh project is trying to find a way of solving all of those same problems, doing all of those things, but at a much lower overhead.
So what is the ambient mesh? Because that's not really clear to me, because I know the service mesh. You had your colleague App Heiting in episode 20. He explained what the service mesh is. Now I heard the first time for me is the ambient mesh. Can you a little bit explain to me?
Yeah. So what we are now calling sidecar mode, like the way that the service mesh is implemented, and just for people who haven't, you should go back and hear episode 20. I hear it was absolutely fantastic. But for people who aren't familiar, the service mesh is this idea that if we take all of the workloads, the network endpoints in our environment that would need to talk to each other, and what we want to do basically is encrypt all of the traffic between them, give all of the workloads an identity so that we can say, hey, it's mutually encrypted, so I know that I'm speaking with you and you're speaking with me. And that allows us to do things like say, well, we're not allowed to speak with each other, or we're only allowed to call certain endpoints. If someone gets access to a service, they break in. Just because they're on this machine doesn't mean they should be able to access your databases. That this service should only ever be able to talk to the things it's meant to. And then you can do all sorts of fun traffic routing things at that point as well. Like once you're intercepting all of that traffic, you can say, well, I'm just going to have 20% of it go off to a test environment that I'm building. These are things that, again, you could sort of fake it with Kubernetes if you looked at it the right way. If you had two different services, you basically rolled out a new version of a thing. If you want 5% of the traffic to go to that new version, then you could fake that by rolling out 100 things and then having 5 of them be the new version, 95 of the other. But you don't need that much stuff. Like you don't need to basically roll out 20 and have 19 of them just doing nothing. You want to be able to control the traffic. And so the service mesh is a pattern that allows you to do that. We talk about how it's implemented with these things called sidecars, which is a little proxy service that sits next to every application you run, intercepts your traffic, and does all the magic for you. The fact it's a sidecar is sort of as opposed to the original idea and how things worked at Google, which is Google write all their own software, so they compile a library into each piece of software that does all of this stuff for them. Some of that eventually rolled up into gRPC, but you can't just take your Nginx server or any other application you've got and expect it to work in that way. So the proxy server sitting in front of that solved that problem. That's what the service mesh is. So as I say, like if you have 10,000 services running in your environment, you now need 10,000 proxy servers plus a control plane that knows how to program them and make them all talk for each other. What we've done with ambient mesh is, I should say the ambient mode of Istio, is take the functions that we want to do and found a new way to deliver that. People had experimented in early days with having just one thing on every node that did all that routing for you. And that's, for example, how the original Linkerd version 1 worked. And the main reason you don't want to do that is that thing basically has super user access. It needs to have all the identities of everything on the node. And it sees all the traffic. It's an obvious thing to, it's a single point of failure, first of all, but it's also an obvious thing to attack and be able to control everything.
Yeah, there's the liability.
It is very much so. So what we sort of settled on is, all right, well, it's a liability when it can see into all of your traffic at layer 7, effectively, the application layer. But we think that it's safe to do in a multi-tenant way if you do it at layer 4, just the networking layer. So we've implemented a thing which is called the Z tunnel, or the Z tunnel, for the Zero Trust tunnel, which is an agent that runs on every node. It basically intercepts all of the traffic. It has the identities provided to it, and it can do the encryption of traffic. So everything in your mesh now, basically, instead of having a sidecar for every application, everything gets sent to the Z tunnel on each node. And then that's encrypted when it's sent through to any other node. So it'll go to whatever node it needs to talk to its other workload and pop out the other end. And you can do policy authorization on that as well at layer 4. So you can say this workload may not talk to that one just based on its identity, but it doesn't know anything about the actual applications. It doesn't know the layer 7 stuff. It can't say don't allow access to a put method or a post method rather than a get method, for example. It can't know that. To do that, you still need the layer 7 proxy server. And those things still don't suit being multi-tenant. We don't want to have those things run on each node for the reasons I talked about before. But what we can do is we can say for each type of workload, for each service that you run in your environment, for example, we will run a proxy for that. We call those proxies waypoints. And the thing is that not everybody needs that. Like, it's nice to be able to do this traffic routing and so on, but for a large majority of the people who want service mesh, they just want to turn on security everywhere. They want to say, we have mutual TLS and we've met our requirement and so on. So you can do that at a much lower cost with just one thing running per node, with the Z tunnel agent running on each node. And then you can opt in and say, for these particular services, I would like some layer 7 control.
Okay.
Deploy a waypoint in its namespace. Only traffic related to that particular workload ever sees that waypoint, and the Istio control plane sets up all the routing to make all this magic happen exactly the same way it did with the sidecars.
That's awesome. I was thinking about Cilium. is Cilium is starting to be, or is the CNI
Default
CNI, but is Cilium, because Cilium does also lots of fun things. Is that a competitor to Istio?
Yeah, they went with the single agent per node approach.
Mm-hmm.
So Cilium are expanding into service mesh. They've started out, they've got a fantastic layer 3 product for doing CNI stuff. They make some decisions which we don't necessarily agree with or think are secure. So they can use WireGuard or IPsec to encrypt all of the traffic between nodes. Yeah. But that's not workload aware, and you can't opt in single workload at a time. And the standard that people want is mutual TLS. And because they're not running per workload, they can't offer that. And what they're doing, I believe, for layer 7 stuff is running a single instance of Envoy on every node. And that's multi-tenant with all of the workloads that are on that machine. And as wonderful as Envoy is, like, it does have CVEs and bugs in it every now and then. Like, we don't recommend that you share an Envoy between workloads. I don't believe Matt Klein, the inventor of Envoy, recommends that you do that either. But that's one of those things where we're going to hope that it's mostly okay.
Yeah.
Cilium obviously make a lot of noise about eBPF. Like, it is useful to be able to move traffic around a little bit quicker, but it is not feasible at this point. Like, I think they may have demonstrated as a proof of concept that it is technically possible to do HTTP processing, to run that kind of thing inside the kernel on each machine, but no one's talking about doing that. Like, the fact today that they still reach out to an Envoy signifies that we're not ready for that yet.
Yeah, but Cilium is really a CNI at this moment. But they're getting
it's crossover,
a gray area between the service mesh and the CNI.
The Cilium project has 3 or 4 different components in it. I would say, like, Cilium started out as a CNI. Mm-hmm. They have some security software, they have some monitoring software, and so on. The vendor that makes Cilium would rather that you adopt all of them together, but they are little pieces that you can choose which ones make sense for you.
Okay.
And which CNI works at best with Istio?
Any of them. So we've actually done some interesting stuff. We did a bunch of research at Solo to figure out how to solve this problem, but we now have an agent built into the latest release of Istio that solves problems that we had in earlier alphas of Ambient where it didn't work with certain CNIs, because they will try and program the IP tables rules or the filtering on a node. Our agent will try and program it as well, and they'll end up fighting. But what we've now done is found a way that we can basically take our agent and then ask the pod to take the traffic directly out to bypass that. And as a result, Ambient now works with any CNI, and it will work equally well with all of them.
Bij ACC ICT staat alles in het teken van continuïteit waarborgen voor bedrijfskritische applicaties. Of het nu gaat over Managed OTAP, Cloud en Kubernetes, ze geven hier invulling aan om door samen met hun klanten een toekomstbestendige strategie uit te stippelen voor het gehele proces van ontwikkelen tot en met productie. And where does the API gateway fit in all of this? Because it's also a term we have been hearing a lot of the past year.
And so I'm going to complicate things, because there's the API gateway and there's the gateway API.
Ah, okay. Okay.
Both of them fit in. So I would say that the gateway API, first of all, we talked before about the Ingress API in Kubernetes. So the gateway API was, how do we make a version 2 of that doesn't have all of the problems that version 1 had? And it turns out how you do it is you look at the APIs that Istio came up with, and you sort of try and apply them to how it would genericize for Kubernetes. So for all of that complexity we talked about before, there were 4 different APIs for controlling various amounts of traffic. And that's because you want some of them that are configurable by the people who host the service, and some of them that are configurable by the people who call the service and what you want to do. And so we didn't get it right to start with, but the evolution is basically such that the gateway API, as designed for getting traffic into a cluster, doing north-south, with a little bit of extra effort, could be used for east-west traffic, for service mesh traffic.
Yeah.
So you can use that to control
that's
how you publish things inside a cluster. And so we kicked off a project when I was back at Google. I got a project together with Microsoft and with people at Console and other people involved as to how we could use the Gateway API for, I think we ended up calling it Gateway API for Mesh Management and Administration, or GAMMA for short. Superhero kind of name. And a great team of people went out, basically figured out how this could work. And we have a standard now which applies for most traffic use cases. Istio fully supports that. And the good news there effectively was that you can take a definition and say, here's how I want to set up these rules inside my cluster. And you can switch out implementations. So you could take Kuma, Istio, Linkerd, anyone that implements this particular thing, and use the same set of rules inside your cluster as you can with an ingress. You should say, hey, I just map this traffic to here and this traffic to here, and some implementation deals. It's a very Kubernetes-centric. When it comes to API gateway, like that is a service that you can put at the edge of your cluster.
Yeah.
You can use the gateway API to program an API gateway. I sort of belabor the point here because a different product that Solo sells is an API gateway, again, based on the Envoy proxy. And it'll be interesting to see how these things interact. Like it seems to some degree like they are different products for different people. You have API management from a traditional web services, SOAP, XML kind of background and so on. You have that lineage of technology. Plus you've got all this cloud native service mesh stuff. But it turns out with the ambient model that they relate together very nicely. And you'll see some more of that come out very soon.
I will give the talking stick to you, Jan. You can ask the question, and I will think about.
Cool. Yeah, I was thinking about a bit different. Do you have tips and tricks how people can start with Kubernetes and that stuff?
Those cloud things.
Yeah, those cloud things.
It is so hard. Like I put together some very early Kubernetes training, building on the work that my DevRel colleagues at Google had done, and would go out and teach people how to do Kubernetes stuff for a few of the years that I was there. But basically it says, here's how you take Nginx and here's how you build it and here's how you get to 2 things deployed or whatever. And that's great for seeing like what it looks like, but it's absolutely not representative of how things work in production for anybody. And how things work in production for anybody is going to be completely different depending on where you are. Some of the best systems I've seen are platforms built internally so developers can say, here's my code and here's some instruction about how I want to run it. And it will eventually go to Kubernetes and it will be programmed by Istio, but they don't see that. And if you can abstract that away cleanly from them, then that's a win. But when things break, they need to be able to break and see why. And so I don't know that it's for everybody to abstract that away. And the same is true of containers. It's like it used to be, you did what you did with a virtual machine and just download a 600 megabyte image and then put your binary on top of it. And then people swung right to the other extreme and said, here's an empty thing with nothing, and I'm going to put in just the things that I want. And the state of the art today is things like Distroless or Wolfie, for example, which is a very lightweight container images that are regularly updated. But you might choose to build them yourself. You might have a vendor provide that for you. You might get everything off the shelf. You might choose to run everything yourself. And so I don't think that with this, there is a single happy path. I don't think I can say this is how you should do things. There are some things that work better for teaching, and that is true of every chemistry class I did throughout high school. Every year it would start with, that abstraction we told you last year, that was all crap. We made that up to try to teach a fifth form student this. And sixth form, it turns out that the valences are different and the spin or whatever. And then seventh form, it's like, no, that was different. Like, it turns out there's quantum this and that. You've really got to have these abstractions that work along with you as you develop.
So it's a journey.
Absolutely.
Yeah.
And it's still growing. Like the things you can do now are more than when released. Like it's always fun to go back and look at version 1 of these things. And as much as we say things like we launched with a 10-year-old load balancer and so on, Istio was the same thing. Istio launched out of the gate very fully formed and ignoring the new ambient mode features. It looks very much then like it does today because we kind of knew what needed to go in. But there are some things that were built into Kubernetes early on, like, well, this is the expectation from Google about what people might want, but it turns out people wanted something completely different. It was really interesting in the early days of Kubernetes. Google's assumption, which we talked about a little bit earlier, was that people wanted to use this technology to be able to deploy more things onto their computers, to pack more, and that was the thing people would adopt Kubernetes for. But it turned out people couldn't reliably deploy anything. Like there was no decent API for just putting one thing per server and making it stay up. And so many people adopted Kubernetes just for that. They didn't care. Like, don't bin pack anything. That's a problem. Just put one thing per server. It was a win for them to be able to do that. So some things will change as you see what people want to do with them. And some things, it turns out you were right from the beginning.
But bin packing is still difficult in Kubernetes.
It is theoretically very easy, but the implications of it are still true. Like
you need to know your application size very good, and that's the most difficult because developers develop something and they don't know how much memory it's going to use or how much CPU it's going to use. And that's a problem.
You might argue that they should. There is a business case discussion to be had here. Like if something if it makes a lot of money, just throw a lot of servers at it, like optimize it later on. And so when you look at services, like Twitter was always a great example in the old days. It's like it would fail under load or whatever, but it was just so popular people wanted to use it and keep it running. If they had re-architected earlier than they did, then some other service would have come along. Like they couldn't take 6 months and make it reliable. No. They had to have it be bad for a year or two to get over the hump of that, to grow it to the point where they were able to go back and do that work.
But you still see that often. I'm in my professional work. I have a lot of issues with that. That's my main problem with lots of developers. They're awesome developers, but they don't know how big their program is going to be if it runs.
I saw a presentation from a great colleague of mine, a guy called John Wilkes, who published a lot of data out of Google about how Borg and its successor Omega worked internally. It got a lot of anonymized data sets. One of the things that I remember, there was a graph of how much memory or CPU each workload had requested, and it was anonymous. And this is not going to work in an audio medium, obviously, but basically it was sort of a straight line. But there were these big spikes at 10 and 100 and 1,000. Because when you ask a developer, how much does my thing need? They're going to guess, all right, well, maybe like 40, let's round up 100. Yeah. And they're going to pick something. And it's very human to say, this is what I think I will need. And Kubernetes developed a whole bunch of auto-scaling services and vertical auto-scaling along the way to hopefully be able to answer those questions. To say, well, if my thing doesn't work, well, I have two options. Like either I can pay more to spend more resources on this, or I can go back to the programmer and ask them to optimize it. And which of those two things you should adopt depends on whether the service is making money and you can afford to throw more resources at it.
Yeah, it's interesting because we also talked at the Dev World conference where we're at. There are also initiatives to look at code and how can you write code that is more sustainable also. So
you can write it in Rust, that's how.
Yeah, to take that in account. Well, and because I can talk about this, but maybe at KubeCon Intel will present performance profiling. They have built a solution about that. I don't know if you heard about it, but that also also has a hook in what you two, Jan, and you are talking about, because you can look at the DevOps way of working, and with the performance profile, you can see what code or where the CPU will be the busiest at a certain point, and you can optimize that part of your code.
It's amazing to look at profiling technology, and like a great guest that I spoke to was a guy known as Helvar Flake, who is a professional sort of security guy who went into developing tools for profiling that I think were eventually acquired by New Relic. But Google have an internal system. He built something like it externally, and you can basically just look at the usage of all of the things across all of your machines. And the tooling, even just to introspect a single running thing, like I find it interesting. I still have a soft spot for the 8-bit computers that I grew up on. Yeah. And you see people today, like you can simulate the entire thing on your calculator these days. You can just stop the computer and wind back in time and so on, all this stuff. And technology is moving on to the point where we can pretty much do that with the software we're building as well. Like you can record the entire state of the server that it was running on. You may not want to do that all the time. It may be expensive, but you want to do some sampling where you're getting some data some of the time, and then it's able to look, this particular function is expensive. This is where I shall optimize it.
Well, it's interesting stuff to look at, because what I said is also an environmental and sustainability thing to run things more optimized. And, it's...
so that is obviously like the fewer computers you need, even just looking at Kubernetes, to run your environment, the cheaper it is and the better it is for the environment.
Yeah. It's more sustainable.
Sustainable.
And, I'm still back at bin packing.
We're all over the place.
Yeah, of course. And do you have insights how we could bin pack more or get more information about that application?
There are so many different variables and things. Like in the early days of especially Amazon's EC2, like who else was on the same computer as you and how noisy they were was a big problem. Containers sort of hopefully get rid of that to some degree, and you can reliably share. Like the fact that the containers limit what you can do meant that you were able to start packing things together. Mm-hmm. Now you start looking at I/O performance. You look at network cycles and so on. Like everything, it is still computers underneath. Like these things were not built from the ground up to be fully virtualizable. We've just tackled that on. And the security implication, like if I land on the same node as someone else and I can exploit that, then I can look at their stuff. And so that's where things like coming back to the gvisor, which I mentioned before, is like if you run your thing within this hypervisor, then you effectively have another layer that people have to try and break out from. And I don't know if there has ever been a successful exploit of gvisor, but the idea is it's very unlikely that there will be a Docker exploit and a gvisor exploit and a hypervisor exploit all at once. And so that makes it more sensible for you to be able to run multi-tenant environments where you're taking insecure code from people, providing it, just uploading it to run on a service, for example, and you can pack things in more. So there's bin packing, and then there's bin packing in a multi-tenant environment, and there's a lot of different considerations about all.
Still difficult.
Cool. I look forward to reading your paper on how you've solved it.
Yeah, I think it's almost time to round things up because we have talking for almost an hour now, and usually we call it quits at 30 minutes, 45 minutes, but we can keep on going.
I'm too interested.
Yeah, but the both of us, I think
I'll be back anytime.
Great to hear. And
I lack my own outlet for regularity of this, and I've done a little bit of podcasting here and there since I've stopped. I've enjoyed doing guest spots here and there, but it's my time at Google has also coincided with some international movements and family situations and changes and so on. And so what I want to do one day is call Adam up and say, hey, we should do something, but we haven't got there yet.
And otherwise you can hit us up and we can talk about anything you want to talk about.
I can work on the Dutch.
No problem.
Since leaving the UK and coming back to New Zealand a couple of years ago, we still really I don't read the local New Zealand news. I read the BBC, and we listen to a radio station from the UK called Classic FM. And I do this by asking the Google Assistant machine I have to play it for me. And I don't know what's happened, but recently in the last week, and this is not a story, I completely have not made this up for talking to you guys, but it started playing me Classic NL instead.
Oh,
so I'm listening to the
interesting
music station. And the thing is for like 9/10 of the hour, of course, you can't tell the difference because it's the same classical music and so on. But then you get like classical night music and so on. Like I thought I should try and remember some of this stuff to be able to play it. But it's really good because like when you hear the ads, when you listen to a music radio station and the ads is like, buy better car insurance, blah, 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 and so on. But if I don't speak the language the ads are in, it's just so much easier to not pay attention to them.
Yeah.
Find a classical music station from a country that you don't speak the language. That is my free tip for you today.
Okay,
awesome.
Well, talking about tips, do you have tips for people who want to start a podcast about Kubernetes or tech related, or have tips for two guys that are almost for 1 year are doing this kind of thing?
Congratulations,
wink.
First of all. Yes, my advice for what it's worth is have a regularity. Be out there every week. I was very proud. As it was a lot easier when Adam and I were there to bring each other on and provide that. And we never missed a week. We never missed an episode. We took 2 weeks off a year. We should not have done that. Like I have memories of all of the places we would both travel for conferences and so on. Like I've got a screenshot somewhere, but he was outside a motel in Montana, and he would, like his kid and his wife were asleep inside. He'd gone out to his car to do a recording with me. We should not have been doing that.
Great stories.
Good for our work.
Yeah.
But we had something out every week reliably, and that's important. I think that it's building that rapport with your audience, that reliability, knowing that you're going to be there. And whether or not you have something like I always thought that the interview was the most interesting part of my podcast. Adam always thought it was the news. And it turned out it was probably a combination of them. Like people would listen because it was the summary they got of what was going on in the industry, and that gave them a reason to listen and gave them a reason to come back and listen every week.
Yeah, thanks. So, to close up, we always have a final question. So, Jan, you will take the honors.
Yeah, of course. How do you see the future of Kubernetes and Istio?
Ooh, is it the crystal ball question?
Yeah.
That's the analogy I always use. Well, I'll put it on the table, but you're a little bit far away to put it on the table. So,
yeah, I think that there is incremental improvement, and like the ambient work that's happening in Istio at the moment, it's the same feature set, but it's being able to be provided in a way that is not only is it cheaper, but it's also you don't need to redeploy your workloads with the sidecar, and so it's a lot easier to do it. It is getting to more of the platonic ideal of what a service mesh should be, and Kubernetes might have got to the point where like it is the best way to do this kind of deployment. I'm not sure that there's going to be a huge increase in this space. Like everything that's interesting seems to have come about by some new space coming along and disrupting it. If you think back to desktop operating systems, like everything we're dealing with here on Windows or Mac or even Linux, still kind of feels like the Alto in the 70s. And it was, Microsoft was very successful. Windows had all this going on. And then a new thing came along, which was the internet, and Google was really successful there. And so it wasn't that Google came along and displaced Microsoft from desktops. It was that the internet happened, and that was the new thing that mattered. And then mobile happened and so on. And so all of these things here are like some new technology has come along and displaced the old thing. So how do we apply that to cloud native? We'll say, well, like WebAssembly was the thing for a while, saying maybe we're not going to run containers, maybe we're just going to run these magical functions and so on. And maybe our friends at Intel are going to find some way that we run it directly on these multi-tenant CPUs, or maybe Intel are absolutely the wrong people to discuss here because they're, again, very wedded to their x86 architecture. Maybe it's an ARM thing. Maybe the vendors who are building ARM cores or RISC-V, for example, maybe they're going to find a way that we're going to be able to do secure multi-tenancy on the CPU. And maybe that will change the method of deploying things. So I don't see anything more than sort of incremental evolution in the cloud native space because there hasn't been anything major in the last few years. And even some of the things that have been hyped, like we talked about eBPF before, it's nice. It's a convenience for being able to do more stuff and introspect the kernel and so on, but it's not a step change. Eventually, there will be some sort of step change. It would be remiss of us to have a podcast and not talk about AI at any point, but maybe something will come along and we won't be writing code anymore. We'll just be telling the machine what we want.
Should be awesome.
It's going to be awesome.
Yeah, it's always going to be awesome. Thank you very much for your time and for your amazing stories. I had a blast.
Yeah, and we love to have you back in the future.
Thank you both. It's been a pleasure.
Okay, well, see you later. Deze podcast is een initiatief van ACC ICT en wij zijn te beluisteren op onze website k8spodcast.nl via Spotify, Apple, Google Podcast en alle andere favoriete podcastproviders.